Okay, sorry for that. All the internet providers, GSM antennas went off around me. I had to switch to different operator. It took some time. Hopefully will be no problems anymore. If I get lost or something, just wait. I will try to maintain this on the go. All right, guys. Take something to write on, because today just will be just a little different. We'll try it this way because it will maybe encourage you more. After talking with Paulina about the COD classes, she suggests me some things. So take some sheet of papers, take some pens, pencils, etc. Anything to make notes. I don't know if everybody is already here. I will check it in a second, but just take some sheet of papers, take some pens. You will be making notes. I will just show you what to do, how to go with the circuit maker. And then I will tell you what to do with your task. So give me 1 minute more. I will prepare and we will start. Okay, guys, let's start. I'm going to share my screen. My internet is fine. All right. So after you launch the circuit maker, if you have not yet, then again, take something to make notes on. No video tutorial, just try to put it in a way that I'm showing you stuff, and then you try to make the project that I will be showing right now. You do not need to recreate this one. After I finish, like in 30 minutes, I will give you separate tasks to do. Okay, so don't try to follow up with me. I will try to give you extra tasks. Okay, I need to disable the waiting room, or I will not. Okay, let's do it like that. Wait a sec. All right. So let's go back to screen sharing. Okay, I am the circuit maker. Hopefully you can see everything and everything's fine. Let's start a new project. You go for add new project. In the circuit maker, you just need to put some name for that, like project, anything, or project 1, class, anything you can. You get two options. You can go, public, or with the project, which is actually the most preferred for this software option, to go public. And you can go sandbox, so something that nobody will be able to see, but you're going to practice there inside. But you can only have two sandbox projects. But let's say you're going for a public project, and I also would like you, okay, we are saving that stuff. Project, and then let's go to projects. Okay, so let's save. this project. Let's go to project window. I am in a project window, project 1 ET, and here is a team option. And you can add new maker, and I wish you to add me as a maker to your project. So because we are already using some, cloud platform, there's no use to upload stuff to ePortal. You just need to add me as a maker of your project, of course, later on, not now. And if you go for my name without Polish signs, you should be able to see me. I don't know why there is no yet icon of my account. Okay, my profile should already have the university icon, but I will make it in a second, okay? In a second, I will make it, after I finish, I will make it so it will be university logo here, so you will be sure which one I am, because there are apparently more like me's in this realm of circuit maker. Okay, let's open the design then. So let's just open the design of this project. I'm clicking open design. And then on the left comes up a project tree with only one project, my main file. So the next step is just to create a schematic of such a PCB project. You right click on the project file, you go add new to project, and here you have schematic. The name of a schematic doesn't mean it can be sheet 1 or anything. We are not making more than one schematic within that project, so it doesn't matter. And now I have the schematic window. Okay, so we have the working space here. We have the project tree in here. We have the menus. I'm referring here as menus, output, tool, home, and we have icons on the toolbar. Okay, so this is how I refer to the to working with this software. Okay, I will just make some imaginary, let's say, pull-up circuit for an MCU, just to show you how to place elements. And later, as I said, you will be given the different schematic to create. So how to place an element on this sheet? You can go for an icon on the toolbar, which is component. And then you can also right-click and go place component. So to open the database, you go for choose, and for the library that is named Octopart. So this is some huge library with possibly a lot of real elements. In this project here, I'm not particularly focused on a single, let's say, diode or a single resistor, exactly the one. But if you make final project, you probably would like to collect the elements before you make your PCB. But for now, for the first class, I'm just selecting any elements I would like to. And what I would like to at the beginning is some connection to the mini PCB board I will be making. And these connections are often referred as headers. So I'm going to look for a header 4. So 4 input solder connector. And this now is time to make some remark. Some of you know, some of you may not, because you don't have the electrical elements classes. Electrical components divide in two main groups. One is through-hole mounted, which is on the basis of that resistor, what you can see. So you need actually a drill, a hole inside the PCB to put the leg through and solid that. And the second option, this is also those are also resistors, is a surface mounted. So if you can see, which is more common used nowadays on electronics than in the past. So when you get these little fellows, you just only need pads on the top surface of a PCB instead of drills, and you are soldering these resistors or any other elements from the side. So top surface mounted SMD and through-hole mounted THT electronic components. This is what I will be referring to if you didn't know these names before. And let's say that I got the header for sides. This you have the description in this window. Check out in this window. You got a few things in the library. You got the schematic of the component. Okay, so it's some, I don't care right now, but some Molex connector with 4 inputs. All right. Then you have PCB footprint of that. So this is how it will look on the PCB. Now I can actually see that this is through-hole mounted because there are 4 drills in here. And there are also revisions of that. In case of this online sharing stuff, you get revisions of the elements. If this component really has such numbering, and you can find in Google it by that, it's some trademark, maybe actually it's in the description, then someone have revised it and made a correction so you can choose between revisions. And then also for some elements inside, there will be different footprints to check. The schematic will be one, but footprints here is only one for each revision, but originally for resistors, etc., can be more models to choose the footprint from, like, because some resistor can have various footprints, or some MCU can have various footprints. Okay, let's go with this. Okay, I got this element. Okay, and I'm putting element on a sheet. How to work with Altium is, when you use, in general, left button of a mouse is to select and move things, and in generally right button is to drop things, which you will be more familiar with later after this class, I think. Okay, to move through the sheet, scrolling up down moves the sheet that vertically. To move horizontally, you press shift and scroll. Okay, I need to be shift and scroll. And to zoom, you use standard control and zoom in, zoom out. To rotate element, you select this element and use spacebar. So spacebar is for rotating the elements. Okay, let's add new component. I wish to find just some resistors maybe right now. Let them be SMD, so resistor, SMD. Okay, already searched for that. And I'm selecting, let's say, package 0805 resistor. We'll talk more about the details on the next classes. Today, I just want you to make just a few fresh start to PCB making. Resistor with some R0805 footprint. This is fine for me. Okay. Okay, I'm putting like 3 of them with a left clicking. And now to drop it, right click of the mouse, and I'm coming back to the place component. What I would like more is a LED diode. Let's search for LED diode. And guys, this searching is the most freezing part here. It's not your PCs actually, because he's looking in the internet for this database. So he's really looking deep. So this is also freezes for me, and for everybody will freeze just a little bit. Let's take some LED. Okay, let it be this one. We got the symbol of LED. We got the SMD realization of that. Let's put 2 LEDs. What I would like more is some button, some switch. You can also go with button, and you'll probably find in the description something. But I will go for the exact thing like I want, and it's tactile switch. Everybody have seen a tactile switch. Those are tactile switches. So standard, I would say PCB switches, and also in 2 different versions. One is through mounted with legs, you need drills, and second one is surface mounted, like in here. All right, let's go back to circuit maker. Still good ping for me. Let's choose switch this one. Okay. So I get, in tactile switches, both legs are connected together, so you get only 2 options. 2 sides of it, and there's this symbol. Just go OK and OK. All right. Now I have everything. Let's just connect it in some way. Let's just imagine. Of course, you don't have electronic circuit. You didn't have electronic circuits classes yet, so I will not expect from you, some electronic circuit making practice already to be done. Here we are just going to learn how to produce a PCB from the elements. So I'm going to give you a schematic, give you elements, and this is more like graphics classes, I would say, technique, so how to make it. For the electronic circuit classes you will have with Dr. Wiktorowski next semester, I think. So then you're already probably after electronics, or you have it this semester. I'm not so aware of your schedule, but still I do not request here a knowledge from electronic circuits. Okay, let's put these LEDs on with some resistor. Again, space I'm using to rotate. Just some quick connection. Okay, now how to wire stuff. Here is the wire, so you just select the starting point, click it. Okay, now the wire, I'm not holding my left button of a mouse. Okay, I just clicked once. We'll just do it again. Wire, just clicked once, move it around, and search for the next tip to go. Okay, this one. And I'm connecting this one and this one to this one. Important thing is that sometimes you may not know, like in case, for example, of such thing like this tactile switch, where it starts from. Should I start line from here? No, you shouldn't. It's not. It will not really be connected. Each element has a tip. If you zoom in, you can clearly see that those little points in here, there are tips, and you should always connect from tip to the tips. In other way, it will not just. It just will not work. Okay, let's say that I will connect that to this input, and now let's say ground. I need to ground it, and the proper way is like doing it. The proper way, the first way of thinking is doing it this way. No, not this way. Sorry. Okay, I'm taking a wire. I want to wire this, and I want to imagine that I have ground entering at this third point of my design. Okay, this is small design. So right now, this, all these lines did not make it complicated that much. But imagine you get, a lot of elements. I would like to provide, let's say, a ground line or a VCC voltage line to every component. It just can be really, really hard to read such design. So there is another option. Of course, we can leave it like that. And here you got something that is called power ports. Here in the icons, power ports, when you can choose a label for your net, which I can choose ground for here, and I can choose VCC and the input voltage from here, let's say. And now I have labeled this net. So provide those basic, input and output, input voltage and zero potential, I mean. But still, you do not have to do it this way. You can just don't draw these lines at all, even those one. You can move around the schematics to give it, some more clear view. Okay, like that. Okay, maybe a little bit down. Okay, and now you can try to use just only these power port labels to connect the main nets, because the other nets makes no sense, or maybe you have some data buses, but still, I can connect that this is VCC, this is VCC, and this is VCC, and also where is VCC? Also here, so maybe here I would just do it by, oh, sorry, wrong. And this is VCC from that side. Made it right, almost get lost, but still, made it right. Now I have a wire to connect this stuff as I wanted into the tip. I almost made the mistake I told not to make. So from the tip, I'm starting. Come on. Okay, and now ground plus. I'm just selecting ground and telling him which will be ground. It's not the perfect, but I'm still trying to run fast through that because we have lost a few minutes. So now you have the circuit done. Okay, so this is actually the same like previously. Maybe it did not look better in that case of small, circuit, but still using labels is sometimes much more appreciated than just putting everywhere the lines. Okay, let's save that. Now, a thing that is not so obvious in case of this circuit maker or Altium-based software, you need to number the elements, you need to annotate. In that case, you go to many tools, here, many tools. You select the annotate button, icon, annotate schematic. Now a table pops up, and here you can see that there is a proposition of elements with designators. Why designators? Why they are for? You cannot have, on a PCB, elements R question tag, or R1, two of R1s, or the same, in general, designators of the same names cannot happen because software will not be able to differentiate between elements. So in order to that, there is automatic process to do this. Doing it manually is not the best idea because if you have 100 elements, you will be lost in the numeric of resistors or capacitors. You can always reset this number to this annotating, but still from the beginning, you get some designators with question tags. One is with stars, so I will cover that in a second. So you just update change list. 6 changes were made. He's proposing now what will be the annotation of that. You accept the changes, and in Altium, it's always double process. Validate changes, execute changes, okay? Why? If you have bigger project, you would like firstly validate if everything is okay before changing stuff and messed up a lot with the design. So validate changes, execute changes. Two-step process, close, and now this is the current situation, right? If I close it, you can see that you get 1, 2, 3, etc. But this element has was not given a number. He was not given a number because sometimes, and I will also request that from you when we will be making our own elements, this element this is just made wrong because it should be ending with a question tag because Altium is changing the question tags to the annotated numbers, not the stars. If you have such problem with an element, you can always double click this element and just do it. There's no other way, just give him annotation manually. So J1 and OK. So avoid such elements, and when you'll be making elements, I will be very strict to that to create designators well for automatic annotation. Okay, schematic is finished. Now we can save it. And now we can add new to project, the PCB. No other options, so easy stuff. Name also doesn't matter right now. And now we have PCB. This PCB have some grid given in mils, and this is the grid to move elements to place them. If you right click of this grid, go into options and board options. So right click, options, board options. You do have firstly option to change this to the metric Unix. I don't know where you're from, everybody, but still use the one that you would like to, and it's more common to you, metric. And then you can go to the grid, and then you can set the grid of elements. Let's say this is the moving grid of lines and elements. I will set it to 0.1 millimeters, so quite a dense grid for me for moving elements. Okay, I have set the working space. Now I can save this, save the whole project. Compile it even, so save and compile are two options that are checking if everything is fine inside the project. Now when I have highlighted the PCB, I go for menu home, here, project, and now I have option to import changes from project, not update schematics. There is an option that you will make a change in the PCB, I would like to update schematic, but very, very, very rarely. In general, you make a good schematic and then you import changes to the PCB. So I'm importing changes. And again, this, while importing changes, and so here home project import changes, two-step validation. So once I validate and check out if at some point you may have already errors here. So you are stopping from working further and checking your schematic sheet if there are no mistakes in there. If everything is fine, I just execute the changes and then we have it. Close and check out. I have my elements in here. If you will be zoomed in, you will be lost that they are not, they're always here on this corner waiting for you. Let's take all these elements on the board. Again, moving, control for zooming, scroll for vertical shift, and scroll for horizontal moves within the project. Okay, let's zoom in a way to see the grid. Okay, as I have the grid right now, you need to place the components. Of course, they cannot be placed, randomly. If you place them randomly like that, there will be it is more likely that you will not be able to connect them together because of short circuits and impossible line placements. Altium is showing you what will be the final connections between which paths or vias or or drills have to be made later on with this little, I call it spider webs, because they look like that. If you move element, he's showing you with this little gray bodies where in the end it's going to be connected. Of course, it might not be the perfect with his connection. He's showing the shortest. Sometimes we go around and it works for us for the design, but he's still showing the shortest way. Okay, so what I'm about to tell you, and what I'm trying to tell you, is that when you're placing elements, let me check if this will be a good example. Yeah, for example, if you get, let's say, here resistors, and you would like to go with this little path to connect to this upper one, if I place this resistor in that orientation and this one in that orientation, I'll already make a crossing. So this there will be one crossing. Okay, of course, I cannot make crossings. It will be short circuit, which is very obvious for almost everybody. But still, I will have to go around somewhere to make a connection. But if I will rotate this and give it a good orientation, then I can just connect those three together, and I have a free space to go here upwards. And this works for everything. So when you are setting elements, first thing you need to do is, rotating them in a way to avoid the crossings as much as possible. I should give you another example. Maybe somewhere will give me option to do that. Okay, there's no good rotation example. Okay, will be one. Okay, so check out that this element R wants to have connection here and here, and already because just of the orientation of this element, I'm giving myself a problem because here I get, clear path, here I will have clear path just between those elements, not talking about all the others because I can still move them, right? Just between those elements I have clear, straight, let's say, paths. If I will rotate it, I already made a crossing just between those two elements, which is not very nice. Okay, so avoid crossings. Second thing is how to put elements on a sheet. It matters what you would like to optimize, the space or the look, or I don't know, maybe some creative, learning process that you would like everything in line, etc. But still, the best way, I think, I would just save it for a second, is to take a look at the sheet and start from some point. So let's start from the connector, then maybe look at VCC line and then go with the resistors and then go further and further. So, don't go like, okay, I will take this one and this one. You need to think actually which element you're starting with. So let's do it. Let's start with this connector. Let's put it somewhere here and then let's go with the resistors. And I'm now firstly checking, okay, how the resistors are going to work for me in here. Let's say I will give them that orientation. Again, next resistor, I would like to change. Okay, already I have one problem that I'm messing up with these descriptions in here. And if I have so little elements and working on a zoom, I would like maybe to to hide these descriptions. Here on the bottom, you got layers. We'll discuss about layers also at another time. So we got top layer, bottom layer, outlines, etc. The layer that the description is given, this white one, is top overlay. So overlay of something on the top layer, and I can find it right here, right click and hide it. Oh, now it's more perfect because I get a better view. I don't know what is what, I can just guess, but still from the view of the elements I can, and I'm not distracted by this overlay. If you would like to show it back, you go show layers and just show this top overlay back. You can do it with any layer you want. Okay, let's go with VCC then first here. Let's turn it around, this resistor and this one. I can go even, I think, close with them. And another resistor with a VCC. All right, maybe somewhere a diode. Okay, the connection here. I will try to do it dense. Let's try to do it that dense. Maybe it will be possible. And then I will have switch somewhere around. Let's turn it around and switch somewhere around here. Yeah, okay, let's do it that way. All right, let's say I have placed the elements. I don't know if it's perfect right now, but still might be. We'll be using today only two buttons. One will be free, actually. One will be routing, lines, and polygons. We start with routing. So routing actually is connecting now the suggestion he's giving. So I click routing. check out, I have the tool on. This cross tells me you got the tool on. If I would like to pull the tool off, I just right click the mouse button. So left mouse button will be for selection, right mouse button for dropping the tools. So I take this routing tool and let's connect this together. Okay, let's start with these resistors and check out how to start it. I'm just left clicking, dropping the button. I'm not holding the button on my mouse, but I still have it in here and he's showing me the shortest path to go and also highlighting all the paths that I will need to connect together to be this VCC line. So let's start from one another. So left clicking here on this next path and left clicking here on this next path. Okay, now connecting this the shortest way. I'm starting from this left click again. Still didn't happen because he's making, you know, every time you are edging a line, he's going to give you different option to go. So I need to click several times actually to finish, and then right click of the mouse button, and I am free. And I have connected the very first line. Okay, let's connect now this diodes in here, and let's connect this diode in here. Let's connect here the ground plane already. Yeah, seems like it's a good option to do. Okay, I have ground connected also here. Root. So now the only thing that might get me some problem would be this line, but not because, you know, he's suggesting here the perfect connection. I can try to go around with that. Up here, from here to that net. Yeah, we did it quite smooth with no too much of a problems. Let's delete this and put it again more nicely. Okay, I have finished connecting. Quite fast it turned out to be. Maybe I will make just a little correction of this line because it does not really nice. Make it under. Okay, let's say I have finished my PCB. No, of course not yet. Still, what we need is a border. And borders are usually made on a layer that is named keep out layer. So I'm selecting the keep out layer. Here I was at the top layer, and what layer you are already can be seen by selection by the color here. So this orange is a top layer. I would like now to go to this purple keep out layer. And I would like to select the line. And let's make a line around the design. Okay, if you at some point will, you know, start making things, lines, elements at a different layer, let's say I would forget to change the layer to keep out and have made, you know, some here, some border lines, you do not have to delete this. If you go to this option, double click it, you can change always the layer that it's laying on. So changing the layer of everything is possible if you just double click like I did just with this line in here. Okay, so now I get the keep out layer, so I now have the border of my board. The last thing to do is the polygon pour. Here, this button. So you click it. What is a polygon? It's a plane that should be filled. Okay, this board will probably work, no problem, but there is a good way and many reasons that I will not discuss right now, maybe later on classes, another, why we use the ground planes. There are also some cases that we should not use them, but still in the majority we should use ground planes because of the technique that it's done, because of the reliability of EMC of such a board, etc., etc. Okay, so let's create this polygon. Again, here, polygon button. Two options to check for you. Connect to which net? You should select the ground net. Okay. The layer, you are on the top layer already, but still you can check if the layer was this one that you would like to. And here, this sentence, always pour over all same net objects. So this sentence makes sense. All. So all same net objects, this is the option for you. So it will just connect every ground path to such a plane. And you go OK. And now if you have the border, like here, if you would not have this keep out layer, you will have, to be very accurate making, and that check out any shape can happen, even such artifacts can happen if you don't have a border. But if I have border like we did before, with keep out layer, it will be perfectly easy to make such a polygon. Ground, top layer, same net objects, all of them. And now I'm going through from the corner to corner of polygon. I not have to be so accurate because this is a keep out layer. So in the end, I just left clicked all around. Now right click to lose it and check out it. Because it's a keep out all ground, all zero potential plane or that. Okay, so this is the design. And what I would like you to do, and this is what I did, and I would like you to do, sorry for the drawing, I really miss my blackboard or whiteboard in room 142. I need to develop paint skills more, but I just didn't want to show you the schematic because it would just, shortcut for you. I just in Circuit Maker, I didn't want to show you the schematic. I want just to draw something and for you. So what you got here is header 2. You can look for that in the Circuit Maker as header 2. So some input and output. This is actually some voltage regulator, right? Fixed to 5 volts with famous circuits. In the past, LM7805s, now just L7805. So you will find this element as L7805. 2 polarized capacitors, so capacitor electrolytic. You can take a look for 2 ceramic capacitors, capacitor ceramics, input and output. Output for this 5 voltage, input for this voltage transformer, and a rectifying bridge with diode 1N4007. This way you will be able to find those diodes 1N4007. So you got just few elements. This is the ground plane. You can do it with line or you can do it just with ground signs. It's up to you. What I want you to do now, follow the steps. I hope you have made some notes and try to make this design. I'm giving you right now like 2 minutes to redraw this for yourself or make a picture with a phone. Okay, I will go to take a glass of water because I didn't take one with me, and I'm coming back in 2 minutes. And in this 2 minutes, I would like everybody to share a screen, okay? But this will be in 2 minutes. Why? In order, I will be just jumping between your screens and check out how your progress is and helping it turn out very good at the group at 7 o'clock when I've been, giving hints all the time for different people. So they were pushed further with the work. So take a picture of that or redraw that. Prepare your PC to be screen shared. Of course, you don't have to screen all your PC, just the application Circuit Maker. Start a new project and start working. Remember to add me as as editor. But wait a second, I will try to upload there again the university logo. So I will be back in 1 minute. Disable sharing. Try to launch logo and then request you all to share a screen. Okay. So let's try to just start right now and I'll be back in 1 minute.